Hey guys, Joe Jaguar here again, one more time. Your best friend in astronomy. And remember, like, comment, and subscribe because these videos are for you, my biggest and best subscribers on YouTube. I don't care if I don't have the most subscribers like some channels, but I definitely got the best. Let's get this going. Okay, so do you guys have trouble finding objects? Or are you guys located in like a pretty heavy light polluted zone where it's kind of hard to see stuff, or you don't have a go-to and finding things manual is a tough thing? Well, I got a few things here that I think are going to help you. Okay, so let's get on with this. Okay, so if you have a hard time finding stuff, you better watch this video because it's going to help you. Okay, so the first thing I'm going to say you guys need is, I would say, a low power eyepiece. Okay, so what I have here, this is the Meade 4000 32 millimeter eyepiece. This is a super palazzo. Okay, there are some super palazzos that are slightly different. One with 5 elements, most are 4 elements. The super palazzo usually has a rubber eye cup that folds down, a rubber barrel that you can hold it, threaded for filters. Also, some of the super palazzos might be fully multi-coated, not just coated or fully coated. You pay more, so and that's how you can tell sometimes better eyepieces is by their price, okay? Sometimes. Now, so if you have a telescope that's either a little long, refractor, reflector, Dobsonian, whatever it is, Maksutov, Schmidt-Cassegrain, whatever you have, if it's a little bit long and it has a bit of focal length, who knows, 800 to 1,000, 1,500, you need a 1.25" eyepiece. Now, normally in the 1.25", they go all the way to 40 millimeter eyepiece. However, I don't recommend the 40 millimeter, and the reason is a 40 millimeter 1.25" eyepiece is going to have a maximum field of view of 44 if you're lucky. Now, most palazzo eyepieces will be 50-degree field of view if they're a good name brand. Sometimes if you go on those, other cheaper sites and cheaper no-name brands, palazzos can have 40 to 44-degree field of view. That's why you're also paying the cheaper, because I've seen on some of those sites a palazzo eyepiece sometimes $20, $18, but it's only, you're not getting the eye cup, you're not getting the rubber barrel part, it's not fully multi-coated, and it's a 44-degree field of view. That's what you're getting. But a true good quality palazzo will have a 50-degree field of view, and a super palazzo should have 52-degree field of view. So look out for that and get a decent one that has a 52-degree field of view. That's going to give you more space, and the object will be smaller, bigger field of view. It's going to be easier to find your object, whatever you're looking for. Again, bypass, don't get the 40 millimeter. I think the 32 millimeter is about as wide as you can go on an 1.25" format. Besides going like wide field eyepieces like 60 degree, 68, 70, but of course that's going to cost 3-4 times more. So again, what you need if you don't have, and you're having a little bit of hard time finding whatever, is get a 32 millimeter palazzo or super palazzo eyepiece. Get it with a 52-degree field of view, okay? Sharpness is not going to be probably too much more than a entry level one or whatever, but it might be a little bit, but you're get the field of view so it's easier to find. That's the whole point of this video and finding stuff. So just get a good 32 millimeter eyepiece. Next. Okay, I showed this to you guys before, and I even did a video on why the Rigel and the Telrad, I don't have that here right now, are two of the best finder scopes there is. Now, if you have a 5x24, forget about it. 6x30, forget about it. If you have an 8x50, you can still use both of them. So as you guys know from that other video, if you haven't seen or actually show you why, go look at that video. It's called Why a Telrad and Rigel are the best finder scopes. Take a look at that. But with this guy, it basically, wherever that bullseye is where you're pointing to. Now, if you have an 8x50 finder scope, this is just an example. So if you have an 8x50 finder scope in combined, this one is gonna power it more. So this one is 8 or 950, whatever it is. That's gonna bring you 8 or 9 times closer. The 50mm lens is going to let you see more. But I usually, if you just have one, I would prefer this, because when I'm pointing, I want to point it exactly where I want. And with this guy, because it magnifies and because of the lens also and magnifies and collects the light, a lot of times, if there's, let's say, 2 or 3 stars with the naked eye, once you do 9 times and a 50mm lens collects the light, you might see 30 stars there. Which one is the one you're looking for? So this is why I don't like just to use this guy, because when you're in dark sites, you're seeing hundreds of stars in there. It's hard to tell which one you're looking at, well, you know, on this and then on the main telescope. So it's just easier to use this. In fact, 99% of the time, maybe even slightly more, 99.5% of the time, I don't even use these. I just put it in my closet. I just point this guy to where I am. I use a very low 2-inch eyepiece, a 40mm, a 32. I even have a 56mm eyepiece, and I just pan a little bit, and 99% of the time I hit it within a couple of seconds. So you don't even need this unless you're not as experienced. So you aim with this guy, and then this guy will help you like blow it up. It'll be brighter, and if you see something a little hazy or fuzzy in this guy, then look in your main telescope. So that's the second item. Now the third item is this guy here. So this is an angle meter. Now I got this from Amazon. It was only 22 bucks. I'm sure there's a lot better ones out there. Okay, and what this does is you put this on your telescope, and depending on what angle you're on, it will tell you at least the angle or the degree type of thing. Now, why is that important? Now, some people use these for Dobsonian telescopes, and at least it tells you the angle of some things that you need to be. And all you need then is your right extension. So your declination, this will tell you. So I don't know why this would not help you. Now, this one here, I tried it on a couple scopes, and some scopes it sticks more. Sometimes it sticks a little less, depending on the metal, the steel. But let me get you a scope so you guys understand what I'm talking about. This angle right now is at 51 degrees. Now, consider it like the sky has coordinates, very similar to longitude and latitude that we do on Earth. There is slightly different. It's called declination and right ascension. Dec for short, RA for short as well. So when we talk about the sky, we talk about declination. Okay, that's what it sounds like, decline. And right ascension, right, like motion, right to left. Okay, so it's very similar to latitude and longitude. Now, how this can help. Now, let's say, for instance, I'm going to put the Orion Nebula. A lot of you guys know what it's looking at. Here's the constellation. And as you can see, the Orion Nebula has the 3 belt stars are almost located at 0 degrees declination. If you look at the Orion Nebula over here, it's showing minus 5 degrees. Now, a lot of people do that for Dobsonian telescopes. They use this, and they get the declination right, or the deck right, and then they just turn your tube to whatever right ascension, and that sometimes works. But for you new people, why don't you give it a shot? You guys tell me if you found it helpful. This thing was 22 bucks. That's Canadian. See if it helps you. I mean, you should have some type of aid as well, like a map, a chart, a planisphere, that type of thing. So you should have a general idea where this item is. You shouldn't just go blind and just try to point it. That's not going to work, right? So you guys tell me, does it work? Do you find it handy? And worst case scenario, if you don't, you can use this around the house type of thing. But a lot of people use this for, okay, maybe not a lot. Some people use this for Dobsonian telescopes, and it works for them. So there's no reason why this should not work on well, an altazimuth, an equatorial, although the equatorial usually going to have these weird angles, whatever, but give it a try and see if it helps you, because the whole point is making the hobby a little bit easier for you guys to find stuff. And sometimes when you're in a light polluted zone, it's a little bit tough. So give it a shot for 20 bucks. I guess in American, this would probably be 15 bucks. In UK, probably be, I don't know, 9 bucks. Give it a shot for that cheap of a price. And if it helps you stay in the hobby and helps you find the object way faster, okay, it's actually even cheaper than maybe a moon filter. Give it a shot. Hey guys, so I wanted to test out this angle meter, and up there, I guess you can't see, I'm looking at Regulus, which is in the constellation Leo. It's the brightest star. So I did figure out if you aim to it, yeah, and I get 54 degrees, right about there, 4, yeah. Actually, I want to go inside and explain. Okay, guys, so to use this guy properly, it depends on a couple things you guys need to take into consideration. I know before I was talking about Orion, but it's been cloudy for a couple weeks, and I'm kind of late to finish the end of this video, and I wanted to test it. So anyway, Orion's kind of gone now. So we're looking at the next constellation in the spring, which is Regulus, and Arcturus, and that type of thing. But anyway, since I'm 43 degrees north latitude, the sky, so that means Polaris is kind of almost 45 degrees type of thing. Up should be 90, the horizon should be 0. But the thing is, it's not exactly like that. So which means I would say, like, the Orion Nebula, as I was saying before, is actually about 43 degrees north of my horizon. So it doesn't make sense, because the Orion's belt, let's say, is pretty much at the equator or at 0. And the Orion Nebula is about 5 degrees south, or 5 degrees declination south. So it kind of goes like from 90 to 0. And then it goes from 0 to the other 90 again, and so on like that. So the problem is, because we're on an angle, you have to take that into consideration too. So which means, for instance, Regulus, as we were looking now, is at plus 11 degrees north, okay? Now, I'm at 43 degrees north, so which means you add those together. So right now, as I was testing, I was showing you guys, I had to go to about 54 degrees north to actually see Regulus, or it was at least very, very close to there. So that's how you're going to have to use this guy. So you have to know what latitude you're on. So if you're at 0, which is basically at the equator, then everything that the charts say it is going to be fine. But if you're like me, if you're 43 degrees and you're looking at Regulus, which is 11, you have to add now 43 plus 11 is 54. So now you can add this guy, you can tilt this guy, at 54. I can't see what I'm doing. And then that should be where that star is, type of thing. So hopefully that helps. Again, give this a try, and that's how you're going to have to use it. So again, if something is, just Google something and it says it's 20 degrees north declination, then that means you have to add whatever latitude you're on. You should already know that. Wherever you're located, you should know your latitude. But if I'm now trying to find something that's it says it's 20 degree or 20 declination north, okay, that's kind of north of the equator or type of thing, or north of the celestial equator, then I'm at 43 plus 20 is 63 I got to be pointing at. And then all you need is your right ascension to find the objects. So I hope that helps. Anyway, like, comment, subscribe. See you guys in the next video.